So our first speaker is Matthias Ott, who I've known for a while now. We've met at indie web camps. We're both big fans of the indie web. So we were internet friends first, you know, knowing each other's blogs. His blog is matthiasott.com, and you should definitely check it out. You should also subscribe to his newsletter, the Own Your Web newsletter. It's really, really good. So if you're into the whole indie web thing, as you should be, Matthias is the man. But he also he teaches interface prototyping at Matthias University of Fine Arts and Designs, and you know, does workshops and all that stuff about modern web design, and that's kind of what he's going to be talking about today. So here's the thing: at CSS Day, particularly the past few years, I think you'll agree, we've heard about just amazing new capabilities that have landed in the browsers. I mean, mind-blowing stuff. But it always feels to me like there's maybe a bit of a gap between the stuff landing in the browsers and us actually using it in our day-to-day projects in production. It always feels like there's a bit of inertia and we're still sticking to the old ways of doing things. And it would be good to learn how to practically apply all this amazing stuff we've got in browsers now. Well, you're about to learn how to do that. You're about to learn that from Matthias Ott, and I want you to give him a great big welcome. Matthias Ott, ladies and gentlemen.
Thank you. So, thank you very much, Jeremy, for the kind introduction. Good morning, CSS Day. It's amazing to be here. Honestly, being in Amsterdam again, I just walked around the city yesterday, and the vibe of the city is just incredible. But the same goes for CSS Day. So I hope you're all looking forward to 2 days of fantastic talks, great inspirational conversations with everyone, but also making a lot of new friends, because this is what conferences ultimately also are for, right? So remember the Pac-Man rule. My name is Matthias Ott. I'm a user experience designer and web design engineer. As Jeremy mentioned, I also run workshops. I've been working on the web for about 18 years now as an independent designer. This is my Mastodon handle, Matthias Ott at mastodon.social. I'm also on all other networks, so you can pick your silo. And this is my URL of my personal website. And as Jeremy mentioned, I am quite passionate about personal websites, and this is why I created a newsletter about it. It's coming out every other week, more or less, and I'll send out an issue about various topics on personal sites, owning your web presence, just like everything around this topic. So feel free to sign up if you're interested. Now, we already did this, hands up if you were here last year, for example. I was actually last year at CSS Day as well, but in case you didn't see me around, it's because I was actually sitting in my little office in the attic and I attended CSS Day remotely. So it looked more or less like this. Here you can see I watched all the amazing talks, like this very interesting one by Hayden Pickering, but also all the other talks by Miriam, Stephanie, Yuna, Hide, Manuel, so many others on YouTube, and I highly recommend this. So get a streaming pass or a YouTube membership for the conferences you enjoy and like to support them if you can't attend in person. And just like probably most of you, and like Jeremy mentioned, I was just blown away by how much is happening in CSS these days. It's overwhelming, to be honest, but it's also really exciting to be writing CSS today, because CSS is definitely not the same anymore. But on the other hand, this isn't big news, right? Just like the web, CSS has always been changing. It has come a long way since this man, Sir Tim Berners-Lee, invented the web almost 35 years ago. And back then, CSS hadn't even been invented yet. So all people could use to style their web pages were a few presentational tags, like font, small or big, or presentational attributes like size or color inside their HTML. And there was no separations of concerns yet, no inheritance, and also no way to use the power of the unavoidable cascade. And thanks to Zach Leatherman for providing this code snippet. In 1994, this all changed because CSS was born, and the CSS we were writing 10 years later was very different from the CSS we were writing in 2014. And fast forward another 10 years, and the CSS we are writing today is so powerful, but also far more complex than ever before. However, when I sat there last year in front of my screen, in my little office, I felt like this time something was really different. This time, many of the changes coming to CSS just seemed so fundamental on so many levels that it almost felt like a singularity, like there is now the CSS before and the CSS after the early 2020s, the new CSS. Because we can now do things with CSS that were unthinkable just a few years ago. You can now select the parent of an element with has. You can style elements based on the dimensions of its container, thanks to container queries. And no, it doesn't create endless loops, I'm told. And each of those features is already an incredible and long-awaited addition to CSS, and together with all the amazing other features, we can now create flexible and robust components and layouts like never before. And there is so much more, as you will hear throughout this whole conference. The very foundations of how we understand and write CSS have changed radically, but not only that. CSS is also now the most powerful design tool for the web. What do I mean by that? Yeah, you can clap if you want to. It wasn't me, though. For many, many years, creating high-quality websites largely meant that designers used visual design tools to create static images, static pictures of websites, and then handed them over to the developers. And the developers often had to reply with things like, yeah, I'm really sorry, but this stuff you designed, it doesn't work in CSS. Because back then, creating killer websites really meant understanding and literally hacking your way around the limitations and quirks of CSS. So the platform was the limiting factor, and this is now changed to the opposite. CSS has become so powerful that the tools are now the limiting factor, the design tools. And not the first one to notice this, both Miriam and Vasilis, over there, right? posted blog posts about this exact problem just a few days apart from each other back in 2022. Because of the interop initiative, browsers are implementing new features so quickly these days that it is extremely hard for design tools to keep up. And although design tools like Figma, Adobe XD, and Sketch already have much smarter layout algorithms, as you might know, like auto layout in Figma, they are still using very different mental models for design. So the way our design tools work has very little to do with how CSS works. And this is a real problem because it widens the gap between what designers design and what could actually be possible to create with CSS. So on one hand, we could be creating much more capable and resilient and flexible and beautiful websites, but on the other hand, this also means that we create often suboptimal experiences for all the people out there who rightfully expect the website to be a successful, stress-free, accessible, and also enjoyable experience. And at the same time, I don't know if you've noticed this, sometimes it feels like many teams are still effectively closing their eyes a bit to the reality of what the web looks like today. Some of you might know this picture. It was taken by Brad Frost at a conference in 2012. And back then, it was a revelation to see how device fragmentation was already happening. It is a picture that many of you might have in their heads when they think of responsive design, but that picture was taken 12 years ago. So how about today? This is a visualization I created in 2018 based on an earlier visualization by Frank Chimero in a talk he did. And what you see here is a representation of all the screen sizes I could find back then on various websites that listed device specifications. And the fragmentation of viewports was already obvious back then. But recently I took the data that Andy Bell and his colleagues at Set Studio collected for their brilliant site viewports.fyi, and I updated my own visualization with the more than 2,300 viewport sizes in their data set. And this is the result. We really have to understand that the web is vast and edgeless and unpredictable and uncontrollable. We have to finally embrace a way of thinking about designing and building for the web that allows us to cope with this uncertainty. Now, over the years, I've been working with many teams at design studios and agencies. I ran workshops with hundreds of designers, also for Adobe on designing and prototyping with Adobe XD. And from what I am seeing in the industry, many teams, although they are now building systems of components, are still starting their design journey here. You might know this. So, in a way, I too am Ethan Marcotte, a web designer in my 40s, wondering why the industry is designing for one browser and for a handful of screen resolutions. And I hate to say it in a way, but we are still painting pretty pictures of websites for the most part. We are painting static pictures of websites. By the way, is Hayden Pickering here? No, I don't think so. Because I have a t-shirt suggestion for web briefs. Maybe you can call me Hayden if you're watching the stream. So yes, designers are still painting pretty pictures of websites. And while we might have gotten away with this for now, it is becoming a bigger and bigger problem the more CSS and the other platform features are evolving. Because to properly design for a medium, you need to understand it. By not using the platform in CSS as our design material, we are breaking the feedback loop that is so crucial to develop an understanding of the medium we are designing in. And by that, we are limiting our ability to experiment, to play, to prototype, to learn, and to innovate with what is really possible with the new CSS. So the question kind of always was, and still really is, what would happen if we stopped treating the web like a blank canvas to paint on and started it treating like a material to build with? This is from Frank Chimero's fantastic talk, The Web's Grain. So what does it mean to build with or for the web with CSS in such a way that you are working with the inherent qualities of the medium and not against it? In the case of CSS, it means that we finally stop thinking of CSS just as a tool that lets us translate visual designs into browser code. Instead, we should look at how CSS really intrinsically works. So what is the essential nature of CSS and how can we work with CSS offers us? In 2018, Jen Simmons called this intrinsic web design, that we work with the layout system and all the other intrinsic features of CSS to create outstanding design for the web. Also outstanding graphic design for the web. But working with the intrinsic nature of CSS also means that we recognize that CSS was never really about control, right? It was invented as a tool that is about the information and the content first, and that's a big part of the success story of the web as well. What has made it so resilient over the years. The very idea of a flexible and adaptable medium is baked into HTML and CSS. Because only on the web, content can adapt to different screens and devices, and users can adjust the presentation of their content to their liking. For example, by changing the font size and colors. And all this fundamentally changes the role of us as creators, because on the web, we are not controlling the experience, we are suggesting it in a way. Or to quote John Alsop from his seminal article, A DAO of Web Design, if you use style sheets properly to suggest the appearance of a page and not to control the appearance of a page, and you don't rely on your style sheet to convey information, then your pages will work fine in any browser, past or future. And John, by the way, if you don't know this article, A DAO of Web Design, he wrote this 24 years ago, in the year 2000. I was 18 back then. If you are writing a line of CSS, you are suggesting, you're not specifying how something should look. But this also ensures that what we are designing is flexible enough to work fine everywhere. This is kind of the promise behind CSS, and it works to this day. Jeremy over there, he likes to call this declarative design. This approach to designing for the web, meaning that you don't specify or dictate how something should look. You are declaring an intent. You are providing the boundary conditions, the parameters that shape your design and its behavior. But then you let the browser figure out how the design works in a certain context. And I really like that framing. And as should have become clear just by taking a look at all the plethora of viewports before, and the devices and input modes, and the screen readers and network speeds, and so on. Such an intrinsic and declarative approach is probably a good idea when we are designing for the web. So how does this look like in practice then? How do we as designers and developers finally embrace the fluidity, the flexibility of the web with CSS? Let's take a quick look at a few areas where CSS really outshines our classical design tools and how we can effectively work with the new CSS at the intersection of design and development, now that it has become the most powerful design tool for the web. And I'm also intentionally looking at stuff that is already available in major browsers or will be very soon. So not only the very, very new stuff. And let's start with one of the most important elements of any design. And Rül will talk about this in his session in even more detail, typography. When it comes to typography on the web, the lack of control is still a real issue for many designers and also stakeholders, because in print design, we have full control over every typographic detail, right? On the unpredictable web, however, we have to accept this dance with uncertainty, and we have to somehow instead create a set of boundaries or suggestions that makes our typography work in different contexts. And this is where fluid web typography comes in. Fluid typography or fluid type allows us to scale type based on the size of the viewport, so that it works well on any screen without any breakpoints. Maybe just a quick show of hands. Who has used fluid type in a production project before? Okay, so a few people, all right, but not everyone. So this is how it looks like. Instead of just adding more and more breakpoints to your design, whenever the layout doesn't look good anymore, we instead create a system in which elements scale proportionally and fluidly based on the viewport size. And this idea can not only be used for font sizes, but it actually works really well for the spacing, the white space, for example, of our sites too. And this is how it is usually done with modern CSS. We are using the clamp function to calculate a font size that adds a fraction of the viewport width or a container width to a base font size. But we also make sure that it never gets smaller than our minimum and never larger than our max value. The relative font size unit also makes sure that it stays accessible, but it can because it can still respond to font size changes. And just in one word about clamp, in case you were holding back a bit of using it in your projects. Clamp is well supported, just like min and max, and has been available across browsers since July 2020, more than 4 years, so use it. And the idea of fluidly scaling our type is then combined very often with another idea that is really centuries old, a typographic scale. In the 16th century already, European typographers developed a series of typeface sizes that would work with harmonious relationships between the individual font sizes, a scale. And this underlying idea is really that numbers that are related by a certain ratio will feel harmonious, just like in music. And there are various ratios that designers have been using historically. Modularscale.com is a great site by Scott Callum and Tim Brown that calculates various scales for you. And now we can combine those two ideas. We have headings that scale fluidly with clamp, and we are using a modular scale to create a system of harmonious font sizes. And the trick is that we are using different scales for our min and max viewports. So for example, for the smallest viewport, the type scale multiplier is 1.2. For the largest one, it is 1.33. And you can beautifully see how the typography, the font sizes, scale up the larger the viewport gets. And this is great because we can make use of the much larger screen real estate. But on small viewports, we have more pressure on the layout, and so there is less contrast. As a designer, however, I have given up control over how large exactly each font size is on a particular viewport. I could calculate it if I want to, but I can also just trust the browser that it will work fine in any screen. There are many calculators you can use for fluid type. Probably the best and most well-known is Utopia, created by James Gilliard and Tris Mudford. You can enter all your values for min and max viewport units, font sizes, ratios, and so on, and Utopia will spit out a set of custom properties that you can then use in your project. So you don't have to come up with this calculation yourself all the time. And as I mentioned, there are many other generators as well. Utopia now even has a plugin which lets you import your fluid type and spacing values back into Figma. And this is interesting, although it feels a bit like reverse engineering, to be honest, but it can still be helpful to create a system that also works well in static design tools, so the designers can at least use the font sizes and spacing from Utopia to paint their static screens. But what if we don't want our type and spacing to scale up in a linear way? What if we want our headings to scale up very quickly at the beginning to make use of the growing viewport real estate, and then on large viewports grow it much slower, like maybe in a curve like this? There is a tool by Scott Callum, Typetura, that does something similar, and Scott uses a clever hack for this. He takes a CSS animation with an easing curve, and then he stops it at a certain point to create those fluid type sizes. But it also relies on a bit of JavaScript, and so let's see if we can use the power of the new CSS to achieve something like this. And for this, we could use a trigonometric function like this, like the sine function. Or to be more precise, this part of the sine function. And functions like this one are also the basis for easing animations, easing curves. And as you can see, changing the value on the x-axis results in a more rapid change of the resulting y value at the beginning, but then it slows down the more we move towards half pi. And in our case, we would use the min and max viewport widths or container widths as the starting and end points to use the sine curve to interpolate between our font sizes. Now, trigonometric functions are available in all major browsers since last year, so we can confidently use the sine function to experiment with this idea. And this is how our sine function then would look like. I've taken this from easings.net, a site that lists various easing curves. And it's pretty straightforward. If x is 0, for example, the sine function returns 0 as well. if x is 1, we pass pi divided by 2 into the sign function and it returns 1. So we have a value between 0 and 1, and this is what we need. The only challenge is this x here, because this x needs to be a value between 0 and 1 that is relative to the current width of the viewport. And to calculate that, we need the current viewport width, but without the unit. Maybe you remember this from your maths classes back in school. It's quite easy. If you want to get rid of a unit like pixels, you just divide the value by 1 unit. Like in this example where I'm dividing 100 VW by 1 VW, and I get the pixel value, ideally. Except that this here currently doesn't work in any browser. It's part of the spec, Miriam told me, but in theory, so in theory it could be possible, but somehow none of the browser vendors has implemented this specific detail yet. So I'm taking a look at the people in the front. yeah, Adam. There is no way to get a unitless value of the current viewport width with calc that we could use in our trigonometric function, and therefore our whole idea of using the sign function for fluid typography falls apart. At least that's what I thought for a long time. Until Temani Afif pointed me on Mastodon to an article by Jane Ori in which she demonstrates that you can actually use a combination of the tan and a102 functions to divide by units, or in this case, length types. And it's a really clever solution. Here's how it works. It took a while for me to understand it as well. So the a102 CSS function is another one of the newly available trigonometric functions. It returns an inverse tangent of 2 values. So you basically pass in 2 coordinates of a point, and the function returns this angle. The nice thing about this function now in CSS is that it takes 2 values with different units. So this here, passing in 100 VW and 1 pixel, will work. Now the a102 function returns an angle in radians, and if we throw this angle back into the tan function, we are getting the original value for 100 VW back, but without the unit. An amazing hack. There is one little thing we need to do, because a102 still seems to be a little bit buggy in various browsers when you combine those different units. We also need to make sure that we are always passing in the viewport width in pixels, and this is where @property comes in. Also, hurry up, Firefox. You can declare a custom property with @property, but also give it semantic meaning. So instead of just declaring a custom property that basically could be anything, you can say, I want this custom property to be a color, or a number, or in this case, a length. It's like TypeScript in CSS, in a way. If we declare a new custom property and register it as a length, the computed value will always resolve to an absolute length in pixels, and this is what we need. Now that we have our current viewport width without a unit, we can normalize it so that we get a value between 0 and 1. This is what this function does somehow. And then we can put our x into the sign function and then calculate our fluid font size. I will share all the slides after the talk so you can take a closer look in case this was all too fast. But we don't have time to explain it. But this is how it looks like in action. So at the moment, this is just a proof of concept. You can see that the typography scales up very quickly at the start, but then not that much the larger the viewport gets. I wouldn't use it in production at the moment, maybe on your personal site. Personal sites are the perfect playground to try out stuff like this. But it shows you what's possible with the new CSS. And if that's not programming, I don't know what is. We are even using the POW function to generate our various type scales. But it is also design, right? Design in the browser. And also over-engineering your CSS is a lot of fun, right, Kevin? Please also be aware that fluid type can become inaccessible because you might limit the ability to scale your type up to more than, or up to 200%, which is an accessibility requirement. And Sarah is already nodding, so please always test your implementation. Also pay close attention to Sarah, who will talk about accessibility in her talk. All right, let's look at another area where the web platform outperforms our design tools, and that is color. On the web, color has been neglected a bit. From around 1994 until 2016, nothing really happened in the color space. Of course, we gradually moved away from being able to use only 16 named colors to 216 web-safe colors. Jeremy remembers this, I guess. To being able to use all those ways to write colors now. And also our tools, our design tools, let you use those color formats in some forms. So Figma, for example, supports hex, RGB, HSL, HSB, and even lets you enter a color in CSS syntax. But as Chris Lilly put it 2 years ago on this stage, all of those ways to define colors share the same limitation. They are all locked in sRGB prison. Because if what you are seeing here is the range of human color perception, then this is sRGB. Quite small, and that's actually what the S in sRGB stands for. It's the smallest common denominator when it comes to color spaces on digital devices. But thankfully, all of this has changed recently, also because Apple decided to put wide gamut displays into their devices using a color space developed by the movie industry called Display P3. And P3 is a much larger color space, although it doesn't look that much larger, but it has around 50% more volume than sRGB, and it allows us to produce much more vibrant colors. Now, our design tools haven't gotten the news fully yet. So you can switch Sketch and also Figma to P3, but both tools still very much rely on this old sRGB workflow. Figma even tells you that P3 isn't recommended for web design. In CSS, however, we can make use of a set of really powerful functions now. CSS Color Module Level 4 offers new color functions that work with the Display P3 color space, Lab, OKLab, LCH, and OKLCH. Let's talk about OKLCH. It's a so-called perceptually uniform color space. So it is really good at producing different colors which have a similar perceived lightness. And it supports wide gamut P3 colors, obviously. The L in OKLCH stands for lightness, the C stands for chroma, so how colorful is the color, and the H stands for the hue angle, so where on the color wheel are we? And it is okay because it is actually a version of LCH that is more okay in how it produces gradients, but also how perceptually uniform it is. This is how you write OK LCH colors. The first value, lightness, is going from 0 to 100%. The chroma value ranges from 0 to theoretically infinity, but in practice it stops mostly around 0.5, depending on the color. And the hue value goes from 0 to 360. And you can use it with transparency, of course. But you can also use it in production. You could, for example, check for support with add supports and then update a custom property of your color. Another advantage is when you're using OKLCH that besides those more vivid colors, you can create much more beautiful gradients, perceptually uniform gradients. So I guess the projection does not show this perfectly, I guess, probably, but the sRGB gradient at the top uses hex fallback values, so it is clearly less vibrant than the other gradients. It is also much darker and more muddy in the middle than the OKLab gradient below, but the OKLCH gradient at the bottom, it is clearly has the most vibrant colors throughout the whole gradient. And that is because OKLCH, so to say, does not take the shortest path to interpolate between two colors, right through the muddiness, but it takes a trip around the color wheel, and we get a more colorful gradient. And you can also tell the browser, by the way, in which color space it should interpolate the colors of a gradient, just write in OKLCH or in sRGB, and so on. Now, if we compare our OKLCH gradient to a gradient created in Figma, the first thing you might notice is that the Figma gradient is actually quite vibrant. Respect. You can actually paste a P3 color in OKLCH into Figma, and it will convert it into a P3 color. I have no idea how accurate this conversion is. It looks vibrant, but clearly the gradient in Figma isn't perceptually uniform. It's much darker in the middle. So as far as I know, there is no way to create a perceptually uniform gradient in the static design tools most of our designers are using. And the same goes for choosing or picking colors. You can't really pick P3 colors confidently, but luckily there are a few online tools you can use if you want to define P3 colors and fallbacks, like oklch.com by Evil Martians. And if you want to create a whole color palette, which also is really cumbersome to do in the static design tools, you can use Utone, free tool by Alexei Ardov, or also Atmos, atmos.style. And this is really the biggest benefit of working with OKLCH. It lets you create color palettes that are much more accessible because you have more control over color contrasts. In Atmos, for example, you can check your color contrasts against WCAG 2 or WCAG 3 requirements. But you can also create color palettes with the new CSS. And there are a few ways to do this. One would be using the color mix function, which has been supported in modern browsers since mid-2023. Color mix basically lets you mix two colors into one. So using a base color like this indigo blue here, we can mix it with another color like a light gray, and we get a light indigo. Also pay attention to the hue values we are using here, because we don't want to turn the color wheel into a weird direction. We're using the same value. So we could use color mix, but there is also another way to do this, which is even more interesting and elegant, and that's using the relative color syntax, or just relative colors. Relative colors are really powerful because you can easily create complements and variations of existing colors, like darker, more vibrant, more saturated, lighter colors, transparent, and so on. It is super convenient for color palette creation. Relative colors still have a little bit of limited availability. As you can see, Firefox hasn't caught up yet, but let's take a look. No? Yeah, there we go. So from July on, relative colors will be supported by all major browsers. Nice. So if you want to create a variation of the relative color syntax, you can define a new color using a basic color function like OKLCH, and then you're using the from keyword. You tell the browser that you would like to create this color from an origin color, like your indigo blue custom property. And then you provide the output value for each individual channel. You can also leave each channel, like in this example, as is by writing LCH. But you could also change the values for each individual channel, like this one here, where we are using lightness values from 10 to 100%, and the resulting color palette has the same chroma, the same colorfulness, and the same hue values as the origin color, but we are getting a range of our blue. This is how it looks like when you are using this technique for a variation, a range of colors. You can beautifully see how each color in each column has, or the colors in each column have a very similar perceived lightness. So that's great, because we can reliably use it to produce contrasts that are reproducible. But maybe you also notice how the colors at the edges, so the very dark and very light colors, might still be a bit too bright, especially the yellow at the top, for example. So how about we turn down the chroma, the colorfulness of the color at the edges, but leave the chroma at the center more vibrant, for example. And we could use the sign function again for this, right? We already have our function, but this time we are using only half of the sign function, and because we can also do calculations with the relative color syntax, we can use the chroma values of our colors and calculate new values with the help of our sign function. Looks complicated again, right? But here I'm also using a base value for the chroma so that we don't start at 0. But I guess also there are many better ways, much more smarter ways that you could use this in production maybe one day. And this is how the palette then looks like. It's much better. The colors at the edges are now much more uniform. The light colors, for example, look much more pastel-y. Next, we could go on and adjust the chroma for the base values, or the curve we are using for each individual color, and fine-tune it further, but we don't have time for that. So in the future, we will also have the ability to make sure that colors have sufficient color contrast using the upcoming contrast color function. And Leah wrote a great post about this, because we can now, until then, we can calculate this using the relative color syntax as well. So make sure to read this blog post. And in case you want to learn more about and really understand color theory better, so that it really clicks, make sure to read this amazing blog post, OK Color Spaces by Eric Portis. He includes a lot of interactive three-dimensional demos, but most importantly, he brilliantly explains the complex theory behind color gamuts and spaces in simple, plain language. It's a fantastic post. All right. Now, those were two areas where CSS is outperforming our design tools, but the same goes for layout. And Rachel Andrew will talk right after me about layout, so I won't go too deep into this topic. In CSS, we went from hacking layouts together with floats to an amazing mix of wonderful native layout tools today that you can use to really be creative. But for this to happen, designers must also know what is actually possible in terms of layout on the web. And this is why I want to talk quickly about CSS Grid, because also CSS Grid lets us do things that are powerful but impossible to do in most modern design tools. You can, for example, create fully responsive fluid layouts that dynamically wrap and change the number of columns with one line of CSS. As you might know, this is done using the repeat function with the autofill keyword and a min-max function that defines how small our columns can become. But we can also do stuff like this. We can combine columns that have different widths. Like here, the first column has a fixed width of 100 pixels. There is one column that has a flexible width between 40 and 65 characters. And others are filling the remaining space with one FR, and we get really columns that will grow and shrink at different rates. We can define min and max values for the dimensions of our grid columns and rows, and we can adjust them based on from the outside, but also from the inside, depending on the content they contain. This example was from Jen Simmons' fantastic Layout Lab. Still an amazing resource. You might know it already, but many of the designers in your team might not. So send them the link and show them all the amazing demos and prototypes using CSS Grid, because they really show what is possible with Grid. We can even do things like this with Grid. We can make things overlap. We can name the areas in our grid. We can rearrange elements depending on the context. But you probably know all of that, so why am I telling you this? Because somehow the adoption of CSS Grid is still underwhelming. This is from the Web Almanac 2022. There wasn't an Almanac version of it last year, but the next issue will probably come out later this year. But even if adoption is then at 20 or 25%, it is still far too low, because CSS Grid has been supported by major browsers since 2017, for 7 years now, and globally almost 100% of users will have a browser that supports it. But still, the majority of designers, in my experience, still has no idea of what's possible with CSS Grid. And the same goes for Subgrid. I recently heard someone say that Subgrid is basically what CSS Grid was always meant to be. Was that you, Kevin? Yeah. With Subgrid, we are able to use a grid not only for the direct children of the container, but actually use it further down in the tree, like in this layout. The cards can inherit the grid rows of the parent grid, and we have images and type that nicely aligns. And we can even use different gaps within our subgrids. Amazing. That's just one example of the power of Subgrid. And support for Subgrid is also growing constantly. We are now at almost 90%, and you might be able to use it in a way that doesn't break the original layout, or also use it with a fallback, but please start exploring it now. It's amazing, and tell your designers that it exists. And then there are container queries. I mean, who would have thought, right? Not me, but thanks to Miriam and many other people, of course, we can now adjust an element based on the size and very soon also the style of the container it is in. And here you can see the mother of all container query demos, the card. This is all the same element, but depending on how large a container is, in this case, it's the width of the grid columns, we are changing the color or where the heading sits, also the whole layout of the component. By using container queries, we can use our card in different areas of our layout without needing to know exactly where it will be placed in the future. And this allows us to create really flexible components. Now, container queries are super straightforward and easy to use also. You first have to tell the browser that you want to use an element as a container by writing container type inline size. So this is our container. And then you use @container just to write a condition just like you were writing a media query. In this case, if the container is wider than 40 ems, we are changing the color. You can also name your containers with container name, and then use this name in the query below. Using container names can be really useful if you want to be more specific about which container you want to react to, but it might also make your component less flexible, Adam, right? So think about whether you really need a name. And you can also use the shorthand property container then to declare both values, container name and type, in one line. And we can also, using CSS nesting, move our container query up inside our component declaration. And I really like how that looks. Right. Depending on the use case, you sometimes might need a wrapper around your component. Pay attention to that, but I think this is still a small price to pay. Container queries also come with a set of new query units that you can use they let you use a percentage of, for example, the container's inline size, like CQI, for example, and this can then be used for adjusting the spacing in your component, inside of your component. And I've also seen people using it for fluid type, we've seen before, but you can do that, but be aware that then you are mixing a lot of different font sizes in your layout, right? And this whole idea of using harmonic font sizes and relationships then falls apart. So it might still be better to adjust the font size based on the viewport width or the body as a container, and for example, change the sizing step then of the component's font size only. This is what I've done in the demo before. Adoption for container queries is still a bit underwhelming as well, so start using them. This is from the State of CSS survey. Chris Coyer recently asked on Mastodon why this might be the case, and he blogged about it. I believe part of the reason is that we are still very much thinking in viewport widths, and the designers are building their layouts based on viewports. Also, old habits die hard, but I guess adoption will come once everyone has seen how elegantly you can scale and create flexible components. Because container queries are available in all major browsers since early 2023, so you can definitely use them in production, especially if you use them as a progressive enhancement. And there is so much more that I just couldn't fit into the talk, also looking at the time. There is stuff like min content, max content, and fit content, those sizing keywords that let you define how the box of an element should behave in terms of the intrinsic size of the content. There is has, the parent selector, that is so much more than just a parent selector. It allows us to select an element, for example, based on the size of what's inside of it, and we can create even more flexible components that react to not only the context, but also the content. Like here, we are changing the number of columns if the card component has a figure inside of it. There's also the mask property, which lets us mask or clip images, including gradient masks, for example, to create something like this. Or animation, an area where you can do so much in CSS as well these days in the browser. And it has become so powerful, especially now that we have the linear function, which lets us define our completely own individual easing curves, like you can see here in this easing generator by Jake Archibald. There's also the scroll timeline API, which Carmen will talk about tomorrow. I'm very much looking forward to that session as well. Also view transitions. I included a transition for this. And then also anchor positioning, which Tab will talk about. So yeah, I guess that was a lot of stuff to take in. It should be obvious that CSS is really awesome today. We are really at the cusp of a new era in CSS. But all the examples I showed you have something in common. They are clearly something that no design tool can do, and which they are best evaluated and decided in the browser. So to be able to make a decision, a design decision, whether a certain set of typographic scales or color palettes or fluid grid layout will work, we have to see it in action. We have to build with the real material. So to make use of all those powerful features, we not only have to work with CSS as a material, but we also need to change the way we use CSS in our projects and workflows. Because we cannot wait for the static design tools to catch up. We can maybe look for better tools, but also we have to change how we use CSS. First of all, by learning, constantly learning and teaching each other about the possibilities of CSS. So write blog posts like Roma or Sarah do. Create courses like Josh, Kevin, create videos, other learning material, tell the world how awesome CSS is, but also what solutions have worked for you. And then we need to start to use CSS much earlier in the design process again, because working with CSS from the start ensures that our designs are grounded in the realities of modern browsers. It ensures that we are able to make more informed decisions, design decisions, early in the process, and not when all the blank static canvases are already filled with paint and the paint has dried, which we might still sometimes have to do, very often maybe, to develop a general visual design direction. But we need to make CSS an essential part of the design process, again, in which we start to decide in the browser what works and what doesn't, not in static design tools that are only an abstraction layer, right? And for this, we need to build prototypes. I've been teaching prototyping for 12 years, so believe me, they are invaluable. Prototyping is where new ideas are born and really tested and refined. It allows us to iterate very quickly, oftentimes, but it also ensures that we are building the right thing. And it allows us to work with the real material that is the new CSS. So build typography prototypes, color prototypes, layout, animation, interactive prototypes, build prototypes of anything with CSS. And in turn, this will also improve collaboration between design and development when we're using prototypes, which is really, really, really important because building websites is a team sport. Yeah. It could also mean that we switch from still ubiquitous waterfall-like processes to something like the hot potato process, suggested by Dan Moll and Brad Frost. So instead of everyone working in their respective silos, designers and developers pass ideas back and forth, small work packages, small prototypes in much shorter cycles, just like a hot potato. And by that, we are also working collaboratively in interdisciplinary teams. We have to work side by side. We have to share our skills and grow together. This also means, by the way, that we let the devs design with CSS. Who wants to design with CSS, right? Yes, everyone. And now you know what's coming next. It also means that we let the designers write CSS. Again, this topic again. I really mean it. I'm not talking about production code necessarily. I'm talking about acquiring a first-hand knowledge of what it means to design for the web. I'm talking about getting your hands dirty, exploring stuff yourself, about understanding the concepts behind things like fluid type, color, modern CSS layout, and so much more. Because telling web designers they don't need to worry about code is like telling architects they don't need to worry about steel, wood, or physics. I couldn't agree more to Brad Frost here. So, because ultimately, to really bridge the gap between design engineering, the gap that also Jeremy talked about, that holds us back from harnessing really the full potential of the new CSS, we have to create our designs at the intersection of design engineering and have to practice what's often called design engineering. This could mean that we hire people like design engineers who know how to prototype and build web components with modern CSS and who help build bridges between design and development. But it also means that we have to become better at design engineering collectively, as teams, as people with different skill sets working together. You could also call it web design engineering, if you want. But maybe the right term for all of this has always been just web design. And the big mistake we made was to think that we could split up design into and development into two completely separate professions. Because in the end, it is all one. Shortly after creating CSS, Hakon Vium Lee and Bert Boss, the creators of CSS, published a book about their new visual formatting language, and they called it Cascading Style Sheets, Designing for the Web. Designing. CSS is so much more than just a means to an end. Regardless of whether you understand or wrestle with the cascade or how much you try to control the output, CSS is the very material all of our websites and every design on the web is created from. CSS is the most powerful design tool we have on the web today, and we need to get back to creating amazing, cool graphic design on the web, not by imitating print anymore, but by using the medium, using the new CSS itself. And we also need to build websites and components that are resilient, flexible, beautiful, and accessible, because our websites can be so much more still what they are today. Now is the time to learn the new CSS and build amazing things with it. And I wish you all a fantastic CSS Day 2024. Thank you very much.
Thank you very much, Matthias. I think everyone would agree that was the perfect opener. We don't have too much time for questions, I'm afraid, so do go and grab Matthias afterwards. I think I've only got time for one question, so I've got to make it good. You've already answered the big question, should designers code? Let me kind of reframe it then. And a lot of people were asking about this, how do we bring designers along on the journey? Are you saying, Matthias, that everybody needs to be a unicorn?
I remember that Hayden Pickering got asked a similar question last year, and I can only, in a way, repeat his answer that if you're using CSS, it is a tool to make decisions, right? And so you have to think about how you can include it into the design process, but this doesn't mean that necessarily everyone has to become a unicorn and has to code, but you could also just have a team that does it together collectively. But in a way, I really think that we need to work with CSS much more than we have done it for the last few years, right?
Easier said than done.
Yes.
The way when people have a way of doing things, to change a process, inertia is a powerful force. Yeah, there's clearly a lot to talk about here, so I hope you will grab Matthias and pepper him with your questions. Oh, I did have one come in. This isn't a question, it was more of a comment, but it's a good comment because it comes straight from Mozilla. You asked about @property.
Oh, yes.
It's landing in beta next week.
Yes, so, great.
It's coming. So like I said, you can right now go and talk to Matthias upstairs because we're going to have a break where you'll get tea and coffee. And remember, do not bring your glasses downstairs. Decant into the paper. And you need to be back in your seats by 10:55. That's when the next talk is. And you don't want to miss that because it's Rachel Andrew. But before you go get your coffee, can you give it up one more time for Matthias Ott?